Can you imagine a world where Formula One engines had no restrictions? There are no rules at all. Nothing limiting you, be it on configuration, capacity, materials, or even hybrid systems. This could be either phenomenal or pretty disastrous, couldn't it? Coming up with something like this puts a lot of interesting questions in our minds. For example, what engine configuration would one consider to be optimal? Or what would teams prioritize more? Would it be smaller, lighter engines, or the ones on the larger side with a lot more power? And how can we incorporate hybrid systems into the mix? And most importantly, what would designers do to maximize speed around a circuit? Well, to be able to find solutions to all our queries, let's dive into all the different possibilities of a no-rules F1 engine. Historical inspirations, wild engines of the past. Now, before we get all excited about how these futuristic vehicles we have in our minds might actually pan out, let's take a brief but fascinating trip down memory lane. We're revisiting some of the most unconventional engines ever seen in F1 history. Yes, these very engines not only set a foundation that broke the traditional mold, but also pushed the boundaries of innovation, even though they sadly didn't achieve the lasting success they deserved. The Pratt & Whitney turbine engine. First up, we have this wonderful engine from the late 1960s. It was Lotus that experimented with a turbine engine in their F1 car. Where did they get their inspiration from? Well, none other than the STP Paxton turbo car that almost won the 1967 Indianapolis 500. Now, this engine worked on the same principles as that of a jet engine. How does that work, you may wonder? Well, it begins by compressing incoming air, combining it with fuel, and igniting it to create a very high pressure gas that spins a turbine. A fun fact about this engine is that it competed in 6 F1 races, but guess how many it finished? Only 1. The issue here was that the turbine's potential was very clear, but ultimately when it was applied in F1, it was anything but successful. The Subaru 1235 Flat 12. Another design that we could consider very unconventional was brought to us by Subaru in the 1980s. This one was a flat 12 engine, the 1235. What was most complex about this engine was its 3.5 litre engine capacity that couldn't do without cooling ducts. And we know for a fact that something like that could totally compromise the car's aerodynamics. However innovative the layout was, the engine was sadly underpowered and couldn't meet even the qualifications of many races. This is what led to Subaru abandoning F1 altogether. The Life W12 engine. The Life W12 engine, with its unusual 3-bank design, is a very wonderful example of an engine that totally went against the rules. It sure was one innovation that pushed the boundaries. While the W configuration is successful in road cars like the Bugatti Veyron, the case wasn't exactly the same when applied to F1. What was the issue? Well, for starters, the engine was quite underpowered and unreliable, and it sure didn't qualify as one suitable for a race. Now, coming to the part of this video that was most anticipated, the designing of a no-rule F1 engine. Since we're completely throwing rules out of this chat, what are the factors that will need to be taken into consideration? For example, what engine configuration would be the best? Well, to determine this, we need to consider several factors: configuration, forced induction, like turbos or superchargers, hybrid systems, materials, and the optimal RPM and horsepower. Engine configuration. Finding the perfect balance. Over the years, F1 has witnessed an astonishing variety of engine configurations, ranging from the compact 2-cylinder V-twins of the 1950s to the colossal 16-cylinder powerhouses of the 1960s. However, in a sport where innovation thrives, the absence of strict regulations makes choosing the right engine configuration a decision of immense importance. It's a choice that can make or break a team's success, emphasizing just how absolutely critical it is to get it right in such a highly competitive environment. Single-cylinder engines. While simple in design, a single-cylinder engine is highly impractical for F1 racing due to its severe limitations. The lack of power strokes and inherent imbalance make it unsuitable for the demands of high-speed competition. To achieve significant displacement, a large heavy piston would be required, which would inevitably lead to low RPMs and drastically reduce performance. Moreover, the mechanical stress on the engine components would be immense, significantly increasing the risk of catastrophic mechanical failure during a race. This makes it a poor choice for the precision and durability needed in Formula One. Inline engines. Let's just say inline configurations like those that are used in the inline 8, let's say Mercedes for example, all the way back in the 1950s can sure promise us better performance. We can still state with full confidence that the BMW 1.5-litre turbo inline-4 from 1982 is even today one of the most powerful engines in F1 history. Why so? Only because it reportedly produces around 1,350 horsepower. But the downside to this is that the packaging and height issues of inline engines make them a little different than what we require them to be. Flat engines. The next factor to consider is flat engines. Some of us know them better as horizontally opposed engines. What's so peculiar about these engines is that they offer a low center of gravity with a much more enhanced packaging efficiency. But with this pro comes another con. It's their width. Yup, they can be a little too long, and we know for a fact that if an engine is too wide, it can disrupt the aerodynamics. One very good example of this is seen with the Brabham BT45 from 1977. Despite these challenges, the flat configuration is more promising than inline engines. W and U configurations. Next up, we have our W and U configurations. These offer some of the most compact designs, so in this case, we wouldn't be worrying about length or width disrupting aerodynamics. And what's so great about these configurations is that we've actually seen success in road cars. What could go wrong with these rights? It's their complexity and poor packaging for F1 applications that make them a little less liked by most. A perfect example would be the failure of the W12, which very clearly highlights these issues. The V configuration. Now we've come to probably the best choice of engines for most F1 cars, the V configuration. Why is it the best? Only because of its close to perfect balancing of length, width and height. And of course, let's not forget the ideal number of cylinders it can accommodate. These are more than enough reasons why it's been the most common in F1 for decades, with options ranging from V6 to V16s. For our no-rules engine, a V12 boasts an ideal balance between power, size and reliability. It allows for large bore sizes without requiring extreme RPMs, which is crucial for maintaining engine integrity. Forced induction, turbocharging versus supercharging. When it comes to forced induction, turbochargers are the clear choice over superchargers. Turbos offer a superior power-to-weight ratio and can generate significantly more power by compressing intake air. In F1, turbo engines first appeared in 1977 with Renault, and by 1985, the difference between turbocharged and naturally aspirated engines was stark. For example, McLaren's 1.5-litre turbocharged V6 produced around 850 horsepower in race trim, compared to just 520 horsepower from a non-turbo 3.0-litre V8. The increased power from turbocharging, combined with advancements in managing turbo lag, make an essential component of our no-rules engine. Hybrid systems. Now, how can we not talk about the hybrid systems? These have become such an integral factor in F1 today, especially through components like the MGUH and MGUK. These systems are great at capturing energy that would otherwise be lost as heat and converting it into additional power. Though they could be a little on the heavier side, the instant torque provided by electric motors and the efficiency gains from harvesting energy make them a really good addition to a no-rules engine. Particularly when speaking about the MGUH, it helps so well to manage turbo lag by keeping the turbo spinning even when the driver is off the throttle. So we guarantee the driver a continuous boost in power. Materials and construction. With no restrictions on materials, F1 engineers could fully exploit the most advanced composites and alloys available in the world of cutting-edge technology. Titanium, carbon fiber, and other lightweight, high-strength materials would become the ideal choices for crafting engine components that are not only lighter, but also far more durable. By reducing the weight and increasing the strength of these critical parts, engineers could achieve higher RPMs, improve fuel efficiency, and significantly greater overall performance. This will lead to engines that are faster, more resilient, and capable of pushing the limits of what's possible on the track. The ultimate F1 engine. So finally, what does an F1 engine look like in a world with no rules? We'd assume such an F1 engine would likely be a turbocharged V12 utilizing a hybrid system with some of the most ideal cutting-edge materials. This configuration balances power, efficiency and reliability while fitting within the constraints of F1 car design. The V12, which would be the perfect engine, allows for a high number of cylinders, which reduces the mass of individual pistons and permits higher RPMs, which is exactly what we're looking for. Turbocharging significantly boosts power output, and the hybrid system ensures that energy is not wasted. In the end, while some configurations like the W12 or turbine engines offer some really crazy possibilities, the tried and true V12, powered mostly by modern technology and materials, would still reign supreme. This engine would likely produce upwards of 1,500 horsepower, pushing the boundaries of what an F1 car could achieve on the track. And isn't that what we're trying to achieve by breaking the rules? With such an engine, the lap times will be blisteringly fast, showcasing the incredible potential of F1 engineering when unrestrained by regulations. And with that, we've come to the end of our video. Share your thoughts about this no-rule engine in the comments down below, and don't forget to like and subscribe before leaving. Thanks for watching, and we'll see you in the next one.